All right, today I'm going to talk about this Leetcode problem 236, lowest common ancestor of a binary tree. So you're given a binary tree and you want to find the lowest common ancestor of the two nodes that are also given to you, P and Q. And the lowest common ancestor is defined here is basically a node that has P and Q as its ancestor. And it should be the lowest possible node in a tree. For example, if you look at this tree here, this is the same as this tree here. So let's say this is level 0 or 1, this is level 2, level 3, level 4, right? And you're looking for 5 and 1, which is 5 and 1 here. So the lowest common ancestor would be 3. But for example, if you were looking for 6 and 2, the lowest common ancestor would be 5. Although 3 is also an ancestor, but it's not the lowest common ancestor. Similarly, in this example, so you're looking for 5 and 4. 5 is itself, its own ancestor, and also you have 4 somewhere underneath 5, which makes 5 the lowest common ancestor here. Similarly, so I tried to draw some example here to make it more clear. So you're looking for 5 and 1. This is same as the example shown in the problem description. What happens is that we first go and search the left subtree. You can see here the left subtree and try to find either 5 or 1. And if we find one of them, we somehow mark it. We keep that in mind. We hold that, right? And after that, we go and check the right subtree and to see whether we can find a node or not. For example, in this case, we go to the left subtree, find 1, find 5, and we go to the right subtree, find 1. And then because the lowest common ancestor of these two would be 3, we return 3 as the result. Note that based on the problem description, all the nodes have unique values, so you don't have repetition. So there's just 1, 1, 1, 5, and also they're defined as 3 nodes. They are not just values. Keep that in mind. So in another example, let's say you have 6 and 2 and both of them on the left subtree. The way we're going to approach this is we start from the root and we're going to do recursion as you're going to see in the code. We start from the root, we go to the left subtree here. Now our new root is basically 5, the root of the left subtree, right? And then you go to the left subtree of the new root, which is 6 here. You find 6, you mark this one, you hold on to it. And then you go to the right subtree of the current root, which is 5. You find 2, you hold on to it. And then as a common ancestor of these two, lowest common ancestor, you return 5 as a result. Note that 3 is also common ancestor, but it's not the lowest one based on these level things that I mentioned earlier. So this is level 1, this is level 2. So you want to find the lowest level, highest level in this case. So that's why, because 5 is level 2, you return this one as the lowest common ancestor. The last example is similar to the second example in the description, I guess. Oh no. Last example is somehow you have one of them in the left subtree and the other one on the right subtree. And regardless of where they are, if the two nodes are in two sides of the root, then your lowest common ancestor is the root, regardless of where they are located. The way we're going to approach this problem is using recursion. So personally, I find recursion and mostly when they're combined with trees, one of the most difficult problems, at least for me to handle. So I guess doing the practice a lot and try to understand the code in a way, try to write it down on a piece of paper probably is going to be helpful for you. So how we're going to solve this problem. So for any recursion problem that we do, if you want to solve a problem using recursion, we need to come up with a benchmark or with like some base cases in which if you hit, you're gonna move back up. right? Because in the recursion, as you may remember, we are moving from top to bottom, and when we hit the base case, we move backward up until we get to the original place that we started from. Here, for example, we start from root. You go down, down, either left or right subtree, find the nodes we're interested in, and then we move backward up until we get to the root, and then we decide what is the lowest common ancestor. So in this case, the root, if we find either of the P or Q, it doesn't matter if it should be both of them, but if we get to a node that either is P or Q, we return that node as one of the, basically, we hold on to that node. We keep that node in mind somehow. If we start from the root and this doesn't get satisfied, we move to the left or right subtrees. Let's say root has a left subtree. We do something, and if root has a right subtree, we do something else. And then based on what is the output of these two, we decide what's we're going to return as the lowest common ancestor. Before starting the recursion, we need to define some variables. I'm defining left and right as none because at first we don't know what they are, but we're gonna update them if we get to find one of the nodes we're interested in, P or Q. And here is what recursion comes into the play. So you call the function again, this time on the left subtree. All right, so you start from the root, you come down, go to left subtree, and this calls the function again, but this time root is your left subtree root. Basically, for example, in this case, you start from 3, but now you're at 5. And then if you find the node you're interested in, for example, in this case, P is 5. So you find 5 here, you return root, which is 5, and then that's what gonna be the new value for your left. So now left somehow holds onto the node 5 for you. And since you find the left you find P already, now you go to the right subtree and you try to update right variable here. Again, doing the exact same thing this time on the right subtree, but you can't find anything because none of the nodes. Oh wait, here Q is on the right subtree, so basically your right gets the value, gets updated. It's not none anymore, and it includes this node, basically holds onto this node. Now your left points at 5, your right points at 1. What you're gonna do, you know the answer, the lowest common ancestor is going to be root, but how we're going to decide on this? We say if we have both or left or right subtree, meaning both left and right are not none anymore, both of them got updated somehow, then root is the result. But if one of them is none still, right, we return the other one. Let's say if left or right, left has some value and right is still none, then we return left. Or if left is none and right is not none, then we return right. So going back to the example we talked about earlier, for example here, so you start from 3. This doesn't do anything because P and Q are not equal to root, right? They're not equal to 3. You go to the left subtree. You define these two variables. You go to the left subtree, 5. Now your new root is 5. You call this function again, check this line again, bam, you get to 5, you return root. Basically now your left gets to have basically this node saved into it. Now your left somehow points at 5. You're done here, you go to right subtree. Now your root is what? 1. You call this function again, go again, bam, you got the Q, you return the root. Now both right and left got some values. They are not none anymore. Because none of them is none, then you return root, which is 3, which is the correct answer. Similarly, let me bring it up a little bit. Similarly, for this example, you start from 3 again, you go to the left subtree because this line doesn't get passed. You go to 5. Now your new root is 5. You do your left, basically your left recursion, you get to 6. Because you're calling the function again here, now you have your root is equal to p because you already found the p, which is 6. Now you turn left as a new value, which basically holds onto 6. Now you go to root right. Keep that in mind. It's not the root right of the root of the 3. It's the root right of 5. You go here, you find 2. Your q is 2. Good. Right is updated to a new value, and both of them are having a new value right now. That's why you return root. Root here is 5. It's not 3. Keep that in mind. Right? Now your left get. Now you go up because you got the benchmark. You found your lowest common ancestor. You go up. You get to left. Left got updated already. Now you're at root again. You do your right subtree recursion now, but you can't find anything. Right doesn't change. It's still none. Now this line doesn't do anything. We get to here because one of them is none. Right is none here, and left has some values, and we return left, which is basically the 5 that we already found, and it is lowest common ancestor. That's it. It seems complicated, but if you understand the how the recursion works and how we traverse over trees, it's not gonna be that difficult. It's still difficult. This is not an easy problem. So I did check this myself, so it should be fine. Right. Yeah. So that's it. Please